This project demonstrates a simple yet practical DevSecOps pipeline by deploying a basic HTML application running on port 80. The entire process is automated using GitHub Actions for CI/CD. Security is integrated throughout the pipeline by scanning both the Docker image and Kubernetes configuration using Trivy. Instead of using a managed Kubernetes service like EKS, the application is deployed on an EC2 instance using K3S, a lightweight Kubernetes distribution. Traffic routing is handled by Traefik, which acts as the Ingress controller. Once deployed, the application can be accessed directly via HTTP//EC2 public IP. Main workflow. The system flows a fully automated pipeline from code to production, ensuring both efficiency and security. It begins when a developer pushes code to GitHub. This action automatically triggers a GitHub Action workflow. The pipeline first performs a security scan on Kubernetes YAML file to detect misconfiguration early. Then it views a Docker image from the source code and scans the image for vulnerability. After passing the security test, the image is pushed to Docker Hub. The Kubernetes manifest is then updated with the new image version, and the application is deployed to the Kubernetes cluster. Once deployed, the system verifies that the rollout is successful. Finally, a runtime security scan is performed on the cluster to identify any remaining risk. This workflow ensures the security is enforced at every stage, from development to deployment. Demo step. Step 1. Prepare EC2. Create an EC2 instance with at least 1 GB RAM. Configure the security group to allow the following port: 22 for SSH, 80 for HTTP, 443 for HTTPS, 6443 for Kubernetes API. Step 2. Install K3S on EC2. Run the following command to install K3S. Run curl command. Then verify the installation. Run kubectl command. This confirms the Kubernetes is running and Traefik is active. Step 3. Install Trivy on EC2. Install Trivy for security scanning. Run this command. Step 4. Configure GitHub secret. Add the following secret in your GitHub repository. Update your K3S Kuber config file. Follow this guide. Step 5. Push go. Update your application or configuration, then push to the main branch. GitHub Actions will automatically view, scan, push, and deploy. You can monitor the process in the Action tab. Step 6. Access the application. Open your browser and visit http://ec2 public IP. If everything is set up correctly, your application will be live. Demo time. Now we find our project structure. This project is organized in a clean and simple way to separate the application, container setup, Kubernetes configuration, and CI/CD pipeline. The app folder contains the HTML application. The Docker files define how the application is packaged into a container. The KAS folder includes all Kubernetes manifest, and the GitHub workflow directory contains the CI/CD pipeline configuration. Application simple HTML. This application is a very basic HTML page used to demonstrate the deployment. In that HTML, this simple page helps us verify that the deployment is working correctly when accessed from a browser. Dockerfile. The Dockerfile defines how the application is built into a container image. It uses a lightweight engine image. The HTML file is copied into the default web directory. Port 80 is exposed so that the application can be accessed. Engine runs in the foreground to keep the container alive. Kubernetes configuration. The Kubernetes manifest defines how the application runs inside the cluster. Namespace. A dedicated namespace is created to isolate the application resources. Deployment. Deployment runs the application with several security best practices. Runs as a non-user root. User read-only file system. Disable privilege escalation. Display resource limit. User temporary volume from writable path. The email placeholder will be replaced during the CI/CD process. Service. The service exposes the application internally within the cluster and allow other components like Ingress to communicate with it. The Ingress resource managed by Traefik routes external HTTP traffic to the internal service. This allows users to access the application via a browser using the EC2 public IP. The GitHub Actions workflow automatically builds, scans, and deploys your application to Kubernetes whenever code is pushed to the main branch. Trigger workflow. This means the pipeline runs automatically when you push code to the main branch, and no manual action is required. Define job environment. This pipeline runs on a flat Ubuntu virtual machines provided by GitHub. Check out code. This step download your source code from GitHub into the runner. Make your project file available for the next step. Set email tag. This step uses the GitHub commit SSH as a unique email tag. Store it in an environment variable. Benefit: each build has a unique version, easy run back and tracking. Install Trivy. This step installs Trivy, a security scanning tool. It adds the Trivy repository and install the tool to the runner. Purpose: prepare for security scanning in a later step. Scan Kubernetes YAML. This step scan Kubernetes configuration files for security method configuration. Example: running container as root, missing resource limit, unsafe permission. Important: access code 1. If issue are found, pipeline fails immediately. Build Docker image. This step build a Docker image from your application. Start it with a unit version. Scan Docker image. This step scans the Docker image for vulnerability. I'll add a package library, no CVEs. Again, if a high or critical issue exit, a pipeline fail. Log into Docker Hub. This step authenticate with the Docker Hub using store secret required to push the image. Put Docker image. This step uploads the image to Docker Hub, which is available for Kubernetes to pull. Replay image in YAML. This step update deployment YAML. Replay image playhole with the real image name. Ensure Kubernetes uses the latest image. Set up kube config. This step configure access to your kube cluster. It allows kubectl to connect, deploy, manage resources. Deploy to Kubernetes. This step deploy on Kubernetes resources, namespace, deployment, service, Ingress. Verify runout. This step waits until the application is fully deployed. If something goes wrong, it may pull error, crash, the pipeline will fail. Scan Kubernetes cluster. Scan the running cluster. Chat, pop security issue, RBAC problems, misconfiguration in initializer resources.